Hey everybody, in this video I'm going to go over some different types of lathes that you can use for making rod building parts. You don't necessarily have to have one. There's a lot of pre-made parts that are available and will work just fine for most people. But if you're interested in taking your rod building to that next level, you'll want to start looking at different types of lathes. And I'm not talking about rod building lathes that can be used for turning cork grips. Basically just for sanding cork grips or EVA grips. I'll be talking more about real lathes like a metalworking lathe or a woodworking lathe that you can work with a wide variety of different materials. Really, if you have the right equipment, your imagination's your biggest limiting factor. And I'm also going to show you in this video how you can make a real simple mandrel that's very inexpensive out of a piece of steel rod for turning cork grips. I thought that would be a good introductory project and maybe show a little bit of the possibilities of what you can do with one of these. I'll be making more videos similar to this one, going over some different things and how you can make different parts. You can make anything from winding checks to butt caps to full-on grips. You can make them out of a wide variety of materials. It's important that you don't look at this as necessarily a way to save money, because you won't. Initially, you're going to spend a lot more money getting a lathe and getting the proper tooling that you need and all that stuff. In fact, a lot of times the tooling that you buy will end up costing many more times the cost of the lathe itself. So you can't really think about it on terms of as being a cost-saving measure unless you're building rods and selling them at a pretty high pace of output. And I don't say that to try and discourage people. It's just something you really need to be aware of. So really, this is more of a way of just increasing your involvement in rod building. It's kind of like an artist buying the best paints, or something along those lines. We're not going to look at this from a cost standpoint. I will say this: if you do other things, if you do woodworking, or if you build things, make things, if you do electronics, there's all kinds of reasons why you might want a lathe of some sort outside of rod building, and you can use them for those things too. I do a lot of building things, creative type things, and for me, having a metal turning lathe is almost a necessity. I use it a lot. So you might want to look at it from that standpoint too. If you have other uses, then you might find additional reasons to justify your cost on something like this. With all that said, let me try to show you some ways that you can help reduce your cost. If you are mechanically inclined and you understand how to take things apart and put things back together, and you're pretty efficient at doing that, my best recommendation to you would be to look at the used market. You're going to get more machine for your money, and a lot of times you can get a lot of tooling with a used lathe that you wouldn't get with a new one, which will help save even more cost over the cost of just the machine itself. If you look around, I've seen lathes just today, just looking around, that look like they're probably freight damaged, and people are selling them for under $100 that are woodworking lathes. The lathe in my video here is a MCO Compact 8, and these were made in Austria, and they're very good lathes. They have a few drawbacks. It's not easy to find a chuck to fit them, and I've had to order things from Germany to find parts for different things that I needed on it. I paid $400 for my metalworking lathe that you're looking at, the yellow one. I spent a lot of time cleaning this thing up. It was a mess. Just know, if you're buying a metalworking lathe that needs some work, you're going to spend a significant amount of time doing that work. A woodworking lathe is a lot simpler, and it's easier to overhaul one. But you still really need to have some mechanical ability, or at least the drive to learn how to do the work on it. If you're not motivated to do things like that, definitely look at a new lathe. The major differences between a woodworking lathe and a metalworking lathe is that a woodworking lathe obviously is made for turning wood. The difference is that a metalworking lathe is much more rigid. It needs that extra rigidity for cutting metal. And a metalworking lathe will usually have some sort of a power feed for the cutter. On a woodworking lathe, you're doing all the cutting with chisels, and you control the feed rates and how your depth of cut. There's a learning curve for either one. A metalworking lathe will also usually have some sort of way to synchronize your cutter speed, the movement of the cutter, in relation to the speed of the spindle. That is actually where the work is turning. And that's because most metal lathes are set up for cutting screw threads also, which has to be done at a precise space increment. You won't find that on many woodworking lathes. There's a few exceptions that were made a long time ago, but you're not likely to run across one. The other difference is that a metalworking lathe will hold the cutter on a mechanism that's called a carriage. And on that carriage, there can also be a cross slide and a compound angle slide. And both of those can move also to move your cutter in and out. And also you can set the cutter at an angle and move it with a compound slide to cut tapers. But a lot of the parts are real similar between a woodworking lathe and a metalworking lathe. You have to learn how to use it, what to do, what not to do. There's a lot of safety things that I'm not going to get into. Just trust me, a lathe can hurt you, and it will hurt you if you are not careful. Even the smaller one can be dangerous, so don't let the size of it fool you. Mine's not very big, my metalworking lathe. It's got a lot of power and a lot of torque, and you really can't appreciate that until you start using one. So I read up on it, study up on that quite a bit before you make the determination that you want to make the move to getting a lathe. A woodworking or a metalworking lathe are going to have some similar parts. I'm going to start with the headstock. The headstock is the business end of the machine. That's where the turning happens. On a headstock of either type of lathe, you're going to have a spindle, and that is what actually rotates. On one end of the spindle, you're going to have a chuck, and on the other end, there's a through hole that goes all the way through the spindle to the other side. And as you can see, I'm going to put a piece of rod through here, and I'm going to have it go through the chuck all the way to where it's sticking out of the back side of the spindle. Again, woodworking lathes and metalworking lathes will both have a through hole. If you find one that doesn't, I would skip it and look for something else. Here we can see the headstock assembly from the front, and the pulleys are on the left hand side on this model, and some of the pulleys are right in the middle of the spindle, so you don't actually see the belt that runs to them. But on this lathe, all the pulleys are on the left-hand side of the headstock. On the right-hand side, you can see the chuck, and the chuck is where you hold your work. There's a lot of different options for chucks, and I'm going to stick with ones for the most part that allows you to use the through hole in the spindle, simply because there's a lot of times where you're working with a longer piece that you need to be able to go through the spindle. There's some work holding methods that block off that through hole, and they're okay for some things, but a lot of the times you want to have access to that through hole so you can put longer pieces in your lathe. In order to tighten the jaws of the chuck, you'll need a chuck key, and some types of scroll chucks that you can find on woodworking or metalworking lathes use what are called Tommy bars, and there's 2 bars that you use to tighten and loosen the chuck. In my own personal experience, those don't hold work as well as this type of chuck does. You get more holding power with this type of scroll chuck, in my opinion. But sometimes those types of chucks are your only real option because of the spindle threads. What type of chuck you're able to use really depends almost exclusively on the spindle itself. Metalworking lathes have several different attachment methods for chucks. Most woodworking lathes use a spindle that has threads cut into it and you screw the chucks on. Some metalworking lathes use that type of chuck, and a lot of them use different ways of mounting the chucks. So before ordering any chucks or anything like that, you need to make sure you know what your threads are on the chuck spindle or what type of mounting method it uses for the chucks on the spindle. All lathes should have a tailstock. The tailstock is where you can hold things like drill bits in the backside. They can be locked in place so they don't move. The locking methods are different from lathe to lathe, so it will just depend on what type of lathe you have. They will also have some sort of method of advancing something like a drill bit for increasing your depth of drilling. Mine has a wheel on the back of it that you turn in order to increase the depth of drilling. The inner bore of both the headstock and the tailstock should have a taper in it. That taper is used to lock tooling into place. You basically slam home whatever tooling you're using into that taper, and it locks it and keeps it from turning. If you're using taper mounted tooling in the headstock itself, you'll need some kind of drawbar to lock it in place to keep it from spinning out. Because the tailstock doesn't rotate, there is no need for a drawbar on the tailstock side. The drawbar on the headstock is basically a threaded rod that goes into your tapered tooling mounted to the headstock, and on the back side there are washers or some sort of a spacer in order to keep it from pulling through the spindle bore as you tighten it down, and that locks that tooling in place into that taper, and it can't rotate out because of the drawbar. Another part that woodworking and metalworking lathes share in common is the lathe bed itself. They're made in different ways. There's a lot of different types of lathe beds, but the lathe bed is what the headstock is mounted to and the tailstock is mounted to, and it runs the length. It's what gives you the length of your lathe. A term you'll see in the specs of most lathes is swing, and what that refers to is how large of a diameter of a piece that can be turned on the lathe. How much clearance you have from your workpiece and the lathe bed. And that's figured by finding the radius of whatever diameter is the maximum. So for example, if you have a 6-inch swing, that means from the center of the lathe chuck to the lathe bed would be a 3-inch radius. So you could turn a total of a 6-inch large diameter piece. That's some of the basics. Now let's do a little project here. What I'm going to do is I'm going to make a mandrel that you can use for turning cork grips with. It's real easy, real inexpensive. I'm just using a piece of 1/4-inch rod that you can buy at most home improvement stores. Just round metal bar rod that's usually found somewhere around the section where the screws and things like that are. You can find pieces of metal in various shapes and sizes. I'm going to mount it in the lathe and tighten it down in the chuck. My lathe uses a Morris 2 taper in the tailstock, so I'm using a Morris 2 taper drill chuck. I'm just going to slam that home into the tailstock, and that locks that drill chuck in place now. I'm going to use a center drill to drill a hole in the end of the 1/4-inch rod. These center drills will cut a 60-degree taper inside hole in whatever you're drilling in, and I'll show you why we're doing that here in a minute. You can pick up a set of these center drills at Harbor Freight. They sell a set of 5 of them. They're high-speed steel, and they work really well. I've been using a set for quite a while now. You can pick up a set of those for about $6. Now I'm just going to slide my tailstock up closer to my work, and I'm going to lock it down in place using a wrench. And you can use this procedure if you're using a woodworking lathe or a metalworking lathe. The biggest deal is you got to have a good chuck that will hold your metal rod in place. I'm going to run this at 1,000 RPMs, which is really faster than you'd normally use for drilling metal. But a lot of woodworking lathes won't go down much slower than that. Some will, especially the newer ones will go slower. I'm going to show you can do it using these high-speed steel center drills. And I'm just going to add a little oil here to lubricate as I'm cutting. That will help also reduce some heat so you don't burn your center drill up. But we're making such a small and short hole that it really won't make that much difference whether you're running at a high speed or low speed. I'm turning the volume down on this. It's really loud. You'll want to make sure that you're okay with the noise levels that a lathe makes. They're not very quiet, but I didn't want to blow anybody's eardrums out on the video here. Let me show you from a different angle how deep I was going with this. There's a taper on the end of this bit, and I'm going about 2/3 of the way up that taper. I'm not going all the way up the taper. You only want to go about 2/3 of the way up that taper, and that will cut a 60-degree angle in the end of that hole. And I said I wasn't going to talk about safety. I guess I lied. I'm just going to mention take off any jewelry, no long hair, no long sleeve shirts, nothing that can get caught in something that's rotating quickly. And wear your safety glasses. Now we've got a tapered hole in the end of that rod. That 60-degree tapered hole matches the 60-degree live center that will go in the tailstock. There are two parts that are called centers that go into a tailstock or a headstock. One type is called a live center and one type is called a dead center. A live center has a bearing in it and it rotates. A dead center does not rotate. I'm going to use a wine cork just for demonstration purposes. I'm just going to drill a hole in the center of that cork all the way through so I can mount it on our new mandrel. I drilled that hole slightly smaller than 1/4 of an inch so it'd be a tight fit on this mandrel and it won't move on me. Ordinarily, if you were gluing up your cork rings onto the mandrel itself, during the glue up, the glue will hold it to the mandrel. So a 1/4 inch hole would be fine. It wouldn't spin on it because the glue would hold it good enough to keep it on there while you're sanding on it. And you can still break it loose once you're done just by holding the cork grip after you're done sanding it. While it's spinning, it'll break it loose and you can slide it right off. On this one, I'm using a smaller hole. That way it's a good tight fit and I don't have to worry about putting any glue on it or anything. Now I've just slid my tailstock up and I'm going to put some pressure on that hole that we made earlier using the ram from the tailstock to push the live center into that hole and tighten it up to where it's holding firmly there. This live center will spin with the mandrel as it spins. I'm using a razor blade to cut this cork. You'll want to hold the razor blade under the mandrel. If you hold on top of it, if something happens and it gets in a bind, it's going to push that razor blade towards you. Because the lathe rotates counterclockwise normally, that's counterclockwise if you're looking at the chuck. So in order to prevent that razor blade from coming back towards you if something goes wrong, you want to hold it under the mandrel where the cork will be spinning away from you. From the top side, it's moving towards you. On the bottom side, it's going back away from you. And as a demonstration, I'm going to use some open hold mesh drywall sandpaper. I'm going to show you how quickly you can sand cork using this type of sandpaper. I'm just going to do enough sanding on it to remove the print that was on it on the wine cork. And you can also use that same type of sandpaper and turn it on its end to cut small lines into the cork. And that's just a real brief and simple demonstration, but I think you'll get the idea of how you can use this mandrel to help you turn some grips. I think I'll wrap this video up on that point. I hope you appreciated seeing that clean lathe because it won't be that clean again on future videos. I just cleaned it up just to do this little introductory video about using lathes for making rod building parts. There'll be more to come. We'll do winding checks, probably butt caps and grips and things like that also. I hope you enjoyed it. I hope you found it useful. And if you have any questions, leave comments below. I'd be glad to help if I can. I'm not an expert on anything, but I don't mind sharing what little knowledge I do have. So that's all I got. I hope y'all have a good day, and I will talk to y'all later.